Morning everybody. Today I am going to tell you about the cooling curves. As I have told you earlier about the two component system and the representative model phase diagram of a two component system, and it is somewhat like this. So why do we need the cooling curves? Actually, for the experimental determination of a phase diagram, we need two methods for that. Two methods are popular. One is the cooling curve method and another one is the thaw and melt method. So here I will be telling you about the cooling curve method. So what we do now, just consider a point L over here. What does L represent? L is actually above the melting point of both the components A and B. So first of all, let me summarize this to you. What is this phase diagram to you? This is the temperature axis and the composition axis. This is a condensed system. As I have told you earlier, the pressure is kept as taken as constant. So this is the A is the melting point of the pure component A, and this point B is the melting point of the other component in this system B, which is B over here. And AC depicts the freezing point curve of A when substantial amounts of B is being added to it. This AC represents the freezing point curve of A, and this BC, this represents the freezing point curve of B, to which substantial amounts of A are being added. So this is the composition axis, and from here we can get the composition of each point on these curves BC and AC. Moreover, this point C, this is the eutectic point. As I told you earlier, we have the liquid phase here, we have the two solid phases over here, and it is a non-variant point. So this is our eutectic point. The temperature corresponding to this temperature is known as the eutectic composition, and the eutectic temperature, and the composition corresponding to this eutectic point is known as the eutectic composition. So now let's talk about the cooling curves. Now suppose we take this point L. We consider this a system of composition represented by the line L. So we take this point L, and the melt over here, because there will be only liquid melt over here, since it is a point above the freezing point of both A and B. So suppose at point L, cooling is allowed to take place. So what we do is that we will make a temperature and the time graph for it. Okay. Now if the liquid is cooled at L, so no solid will separate out till the point P is reached on this curve AC. And when the point P is reached, what will happen? A will start solid to solidify, and the solidification will result in evolution of heat, which is known as the heat of solidification. So as a result, rate of cooling will be slowed down up to point Q. And what will happen at point Q? The temperature will fall further, and at point Q, the B component also starts separating out along with A. And after Q, what will happen? This is we are having the solid phase here, and this represents the cooling of the whole system, solid system. The whole solid system solidifies at this point. At this point means this is the eutectic point for the composition which represents this. This may be anything. For example, if here this is A, then this will be 100% of A. So this composition can be anywhere. If this is 50%, then this may be anywhere. Suppose it may be 80% of A and 20% of B. It may be anything. This is only for representation and for easy understanding of it. And this will be 100% of B. Now if we plot temperature and the time graph for this system L to S, it will come out to be something like this. It will come out to be something like this. Here L to P, LP, the curve LP, it represents cooling of both the liquids. LP will represent the cooling of both the liquids. And at point B, just refer to that graph, at point P, what will happen? solidification of one of the component will start. The first crystal of one of the component will appear at point P, which is lying on this AC curve. Now refer to that graph. So what does LP signifies? It signifies cooling of both the liquids, and P is the solidification of one of the component starts, and that point lies on this curve AC. Now we come to this solidification of one of the liquid starts, whereas the other will still remain in the liquid state. Now comes the point Q. At point Q, what will happen? The solidification of the component B will also start. Means that is the U technique point. Okay. So this is the U technique point. For what? This is only for the system which is having this composition. What will be the U technique point? Q will be the U technique point. And from Q to Q dash, from Q to Q dash, you can see here solidification is complete. Solidification gets completed, and we are having sorry, actually Q dash. Yes. Here the solidification process is in process, and solidification is taking place, and we are having both the liquid and the solid equilibrium over here. And at point Q, what will happen? Solidification is completed. Now, if we still reduce the temperature or cooling is done, then what will happen? We get this curve Q dash S. We get this curve Q dash S, this one, this curve, and this represents the cooling of the solids. The cooling of both the solids which are being separated means cooling of both the components. So this is all about the cooling curve. Now suppose if we take a bend of exactly the same composition as that of the eutectic composition, what will happen? It will follow somewhat like this curve. This is from L to C and C dash. The temperature will remain constant. This is the temperature and the time curve. So temperature will remain constant, and this represents our solid phase. So this is the cooling of the solid which has been which we are having at this point. This is the U technique point, means solidification of the component starts, and we have this point during this process from C to C dash, the solidification is complete, and cooling will result in the cooling of this solid compound which is being separated at point C. So with the help of these actually that graph, with the help of that cooling curve, we can construct a phase diagram. What we do is that we take different compositions and we construct a cooling curve for those compositions. Suppose I will explain it here only. Suppose we are taking a composition of this much. So what will happen? A graph will come like this. Okay. This will represent the point where on this graph AC where component A starts to solidify. So it will be like this. Okay, and this represents the Q dash S. Okay, so in this way we will construct different graphs. These are somewhat like this, and when we will join all these P points, P1, P2, P3, we will get this curve AC. Similarly, we join all these eutectic points. Just refer to that graph. We will join all these eutectic points which are for different compositions, and in this way a phase diagram is constructed. So I was telling you the cooling law just to tell you about two things, that how can we experimentally determine the phase diagram construction, that how we will construct a phase diagram experimentally, and to show you how we can make use of this property to construct a phase diagram. Actually, phase diagram is constructed on the basis of the cooling.